And we are back at it again. Another one of these. I don't even know what we're calling these. We made up a weird name for ourselves called Science Dums. I don't know if that's what we're calling the series. We don't officially have like a separate YouTube channel for it, but here we are. My name is Edgar Antillon. On the other side, we've got Richard Fletcher. Essentially, two humans who know, I would say, slightly above average science stuff, but
Yeah,
still not a whole lot. And maybe even that is being generous. How would you describe it?
yeah. I dabble in science professionally, and then outside of the professional point of it, I don't know. I do other stuff.
Yeah. Yeah. I think I've already asked this, and I think we've already covered it. But like, what would you say your level is? I know you've got a bachelor's in, is it mechanical engineering or electrical engineering?
Yeah, mechanical engineering. That's and I did a completed my bachelor's in mechanical engineering, North Carolina A&T, and then I did a minor in aerospace engineering, and I work in neither one of those industries. So
And you work in telecommunications.
I work in telecommunications, radio frequency. That's about as far as I can go.
And I think that's the beauty of it, just humans who kind of enjoy science outside of what we do professionally. And I'm in a position where, like, I hope I get it right. I hope I get it right. Today we're going to talk about quantum entanglement and a little bit more about superposition. I did want to clarify some things from last episode, and I think because we are amateurs, I guess, if you will, in the science world, I do want to, like, every episode go through stuff that we said last time that maybe was wrong, and kind of get your take on it. So here are a few things that w- I know for a fact I didn't say correctly, or I didn't communicate correctly, and maybe even got completely wrong, like just completely incorrect. The very first one, and this, I lost a little bit of sleep over this one. I attempted to make an example on how we already see things, because we were talking about quantum tunneling last episode, and I was attempting to explain how we already see things going through obstacles, and I made the connection between Wi-Fi and radio frequencies, and I think I did a poor job at making that as an example, and maybe it was an incorrect example, because Wi-Fi and radio frequencies are electromagnetic stuff. They are waves. They are not particles. They're not solid things trying to go through another solid thing.
Right.
And I think that's where I think I need to clarify that was just an example that we already see, and even that, in saying that the particle was a wave, is incorrect. All, like, by itself, it acts as a wave, and we see it as a wave, but it's not a wave, and that's the stuff that we don't know yet. So, but I did say that Wi-Fi through walls was quantum tunneling, and of course that's not correct. That's just electromagnetic waves. Um, in real quantum tunneling, it's electrons crossing energy barriers they classically shouldn't be. So I wanted to correct that. The other thing we talked a little bit about, and I was a little confused, and I accepted it, and now I know that it's not true. The light going through glass, um,
Oh,
going through glass is not quantum tunneling. Light passing through glass is photons interacting with electrons. They get absorbed and re-emitted. Um, there's effective speed changes, index of refraction, and that's not tunneling. So light through glass isn't tunneling. It's interaction and re-emission. And I don't think we were like super on the wrong path because there are edge cases where tunneling math shows up, but that's not happening in like our everyday windows and all that stuff. So it was a little um there's like small tidbits of truth in what we talked about, but overall it's not it doesn't happen in our windows. That's not quantum tunneling. The SSDs, it's yeah, that one, to be honest with you, I'm still a little confused about. Um, it's not 100%. It just I just don't know enough about it. So maybe we'll talk about quantum tunneling and SSDs later, and then the other ones is the you can't tell which side the particle is on. I think we had mentioned like you don't know which one's at. Um, and the reality is, well, what I've learned, anyways, is that the issue isn't ignorance of location. I've got my notes here off to the side. The issue isn't ignorance of location. What's actually true, the particle doesn't have a definite classical position. The wave function, which is the method on how the math, I guess, on how we figure out the possibilities, spans to both regions. After measurement, it does have a location. It's not that we don't know where the particle is. It's literally it literally doesn't have a single classical position before measurement. It's still a possibility. It's a probability. And then the last one I kind of already talked about a little bit. It's particles turn into waves after observation, and that's not necessarily true. And to be honest with you, because I've got the transcripts of every single one of our episodes,
Mhm.
and I have no fucking clue what I was trying to say with this. But that's not true. Quantum systems are always described by a wave function. The math measurement forces a definite outcome. It doesn't turn into a wave after observation. It loses wave behavior. Particles don't become waves after observation. They're always wave described. Measurements destroy the superposition. In other words, the potential, the probability. It destroys the what if, I guess, if it wills. And then the last one that we should correct is when we talked about frequency and polarity of the Earth in quantum mechanics. I didn't know a ton about it, but this is according to the science. This is speculative analogy,
Mhm.
not something supported by quantum mechanics. So it's more on the sci-fi side and not really supported by quantum mechanics or cosmology. When we talk
Talking about
about
with the multi-worlds theory.
I think that's what we were talking about. I
Yeah.
believe that's what we were talking about is the polarity of the Earth. Um, I don't remember 100%. I just want to make sure we kind of
Well,
clean that up a little bit.
Earth separated by frequency and polarity is my own theory. That's not so.
Oh,
No.
fair. And I think that's what we were talking about because I don't remember like 100% how we got into it.
Yeah.
So this is your own theory.
Yeah.
Got it. Okay.
That's just me adding to that multiple worlds
Then
or
maybe.
multi-worlds theory. Yeah,
Yeah,
that this is possibly what could happen. This is just viewing things how I see
got
them
it.
since I work in radio frequency.
So explain that again for me then, since it's your own theory and it's not something that is it's not out there, I guess, as much. I'm sure people have talked about it before, but explain that a little bit more so I can understand that one a little bit more. Your
Yeah, I
theory.
mean, yeah, my own theory is that the Earth, as we know it in 3D world, works off of the Schumann resonance, but then Schumann resonance has different orders that you can or different frequencies, and I think that once you are able to change those frequencies, then it can change basically the makeup or the density of the Earth to something different than what we normally have. So once you're changing the order of if you change the order of the Schumann resonance, it remains the same, just at a higher order. But if you were to be slightly off, I think Schumann resonance is 7.13 megahertz. I can't remember.
What was it? The
7.13
Schumer?
hertz. Schumann resonance. SCH.
Oh, yeah, I got it.
Okay.
Yeah. So the Schumann resonance is 7.83 hertz.
Yeah, there we go.
Yeah.
So yeah, once you if it's something that's slightly off of that, then I would think that you can actually, I mean, that it defines the basically vibrational pattern of everything else on the Earth, which could change the makeup of the Earth, or uh, to give you a whole different experience or a whole different world experience.
Yeah. How would that tie into the other stuff? Like how would that prove or tie into the multiverse stuff?
Multiverse. Well, that's where that theory is that um, if you were able to separate those by differing frequencies, like I said, it changes the kind of like the density, or it changes the makeup of different objects within the Earth that would normally vibrate at the same Schumann resonance as the Earth. So now, if the Earth is now vibrating at say 8 megahertz or eight hertz instead of 7.83 hertz, slightly off, but not at a second order or third order, you would have a different experience of everything else that's on that Earth.
Would it be a completely different universe though, or would it just be a different experience of the same universe? Right? Because now we're talking about a potential. Because there's enough, I believe, anyways. There's enough evidence where, but even that one is so minimal. It's like so minimal, where the way electricity, EMPs, right? Like that could potentially affect the way you feel. That's what people say. But it's such a minute, small fucking change. People say this about the moon when it's a full moon. Um, it affects the way we feel because the way it's pulling your head and the way it's doing all the gravitational pulls. But the reality is that the difference is so insignificant to the human body that it really doesn't affect our behavior. So
Yeah,
I'm wondering, like, if it just, if you do mushrooms, you're experiencing life differently, but it's not a different world. It's the same one.
yeah. I've never asked anyone who's on mushrooms just to see if it's actually different. Are you actually here? Are you with me?
Well, they're here because we see them. You've never taken care of anybody who's on mushrooms?
No, I mean we
No?
see them, but do they see us?
Fair.
That's
I'm sure they do. I'm sure they do. We have plenty of people we can ask about the whole mushroom situation.
oh yeah,
Um,
we're in Colorado.
yeah, for sure, for sure. So I'm sure we can find somebody that'll help us out. Um, but at any rate, I wanted to clarify some of these things. That's a pretty interesting theory. I just want to make sure that we start off every episode having a conversation about shit we fucked up in the previous episode.
Mhm,
That way we don't at least I don't want to feed into the bad science out there,
mhm.
and give correct stuff. So I
And that was
wrote
a
down
lot of stuff, Edgar. That was like the whole show. Yeah,
no,
so that was a
no.
lot of stuff.
We didn't have to correct the whole show. And we got most of it mostly correct. We got most of the show mostly
Uh,
correct. I would say correct enough to where it makes sense, and at our level,
mhm.
it's acceptable. If you and I were
Okay.
PhDs in physics and this was our field, and we said that, then yeah, people would be like, "You need to get your money back from whatever
Yeah, wherever you
university,
got your
wherever you got your degree."
wherever
Yeah,
they
for
printed
sure.
your certificate.
correct. Yeah, yeah, yeah. Go get that shit back. Um, anything else you wanted to mention about the corrections or say before we talk about quantum entanglement and superpositions?
Um, no, that seems pretty on point there.
Nice.
Yeah.
Um, so then, um, where do you want to start? Quantum entanglement or superposition?
Um, I think we should start with um, let's go with superposition. Yeah.
Yeah. Super basic.
Yeah.
So as far as you understand it, superposition, what is it? What does it do? Why is it important? Um,
Um, it's basically just the particle is not choosing a state yet. It's not choosing what it wants to be.
but it's not the particle, it's the state.
Yeah. So it's existing in all possible states until something or someone forces a decision on it.
Yeah. Yeah, that's basically it. I mean, there's there's not much more to it. It's a state of possibilities of a particle.
Yeah.
Um,
It
and
can exist in all possible states.
until measured. And it doesn't have to be a conscious being, it doesn't have to be a human, it doesn't have to be our eyes that measure it. Another particle can interact with it, and that becomes the reality of that. And this is where it gets really weird. And this is where I think humans on TikTok get it wrong, where they see like, well, see, anything is possible, anything is um we get to control it. We when we interact with it, we make the universe a reality. Like the universe doesn't care about us.
Mhm.
um but
The
it
best
is
real world
very.
example,
What's that?
I would say the best real world example is say
Okay.
you have a light colored car in a dark garage. It can exist basically as a light colored car. That's about it. That's the superposition. Until you actually shine light on it, you can't tell if it's a silver, you can't tell if it's white or whatever other light color. That's probably the best way to say it.
Yeah, yeah, and that one and wave functions, I always conflate, I always tie together, because wave function is the math that
Mhm.
tells us superposition exists within the wave function, but wave function is how we measure it, and the superposition is just the infinite possibilities. The wave function is how we measure the infinite possibilities, the potentials. But yeah, I guess that is a good analogy, and it is just an analogy. It's not this is what it is.
Mhm.
Because you do see that a lot where you're like, I wonder what color the car that is. And
Yeah.
then it's not until you get up close to it and you're like, oh, it's gray or it's light blue, or and then after that, that's what it is in your brain. That's what it
Mhm.
is.
Yep.
The superposition collapsed. In other words, there is no more superposition because it got measured. Your eyes measured the frequency, and now your brain understands what it is, and that's what it is. Again, that's just an
Mhm.
analogy. It's not what superposition is. It's just a very basic description of what superposition is. Yeah, I think that's kind of a very easy explanation of what it is. It's possibilities. At the end of the day, it's possibilities. Um, quantum entanglement then. Because these two are kind of connected. These two
Um,
are little connected. Um, or maybe adjacent, but maybe not. But as you know it, quantum
I would
entanglement.
I
Go.
always describe it as quantum Bluetooth or cosmic Bluetooth. So it's just two particles that are connected, um, or particles that are connected, separated. They can be separated by time, space, um, doesn't really matter, but their connection works exactly the same. Like say if one particle is spinning in one direction, the other particle is going to spin in the same direction or opposite direction. But the moment that the one particle spins in the opposite direction, the other one's going to respond pretty much
But is
instantaneously.
it is it in the same direction, or is it the opposite of it? I understood it as it being the
It can
opposite.
be, yeah. A lot of descriptions will tell you it's the opposite. It can be same or opposite. I don't necessarily know if it matters which direction it's actually spinning. But the entanglement is basically the movement of the two particles that can be separated by anything, time, space, whichever, but their movement is instantaneous.
Yeah,
And
let me look this up really quick. Um yeah, it could be either opposite or same depending on how particles were entangled and what you measure. Um yeah, it could be one or the other. Either way they're tied. So the way it was explained to me and the way that I understand and the way I understand it is the reason, and I don't know how true this is, so I may study this a little bit more and correct it in next episode, but this is the same system. It's not two different systems. It's not two different particles. It is quite literally the same particle split
mm,
in two. It's again, I may be wrong, but it's the same system. I guess it's a better way of saying it. The analogy that I have and the analogy that has been presented to me is as if you take a coin and you slice it down the middle, so that you have heads on one and then tails on the other side. It's the same coin essentially. You put one in one envelope and you put another one in the other envelope. You ship one to New York and then the other one you ship it to London. So they're separated by distance. The person in New York opens up their envelope and they get tails. Well, the other one can't be tails because you already have the tails, so the other one has to be heads. Now, there is initially the thought, well, like maybe it was just a coincidence, maybe um, that's just the way it happened. But like in quantum physics, this is what happens: is there was no predetermined, there was no we already knew which one was heads, which one was tails, because a lot of could have shifted in the way to the person in New York, and maybe put in a box, not an envelope. Maybe that's a better thing. So it can be in any orientation when they open the box.
mm.
Um, but it's not until they open it, the measurement, when it reveals itself as being heads. Had it revealed itself as tails, the other box or the other envelope would have had the opposite of that. Um, that's the way it was explained to me.
Yeah. Um, the only thing that would be different in entanglement is if the person takes the quarter out of the box and flips it over. The person that on the other side or whatever is their coin is going to flip over at the same time.
Well, but would it?
I mean, that would be entanglement. That's how that works.
So it's continuous. It's not. It doesn't collapse.
Correct. Yeah, superposition would collapse it. That would be it can exist as heads and or tails and until it's observed
Yeah, but
or evidence.
then it wouldn't be continuous because once you measured it,
Hmm.
um, huh. So I'm gonna not that I trust ChatGPT 100%, but just really quick. Um, ChatGPT says this is the fork in the road question, and the honest answer is we don't know for sure.
Hmm.
So again, I'm not trusting ChatGPT. I'll study this after. I'm not going to study it right now, just in the interest of not having a bunch of dead space.
Yeah.
Um, because that wouldn't
And
make sense. Because if I have a coin, and again, we're talking quantum, and this is why it doesn't make sense in my brain, because the quantum world is not the same as classical physics, and I get that 100%.
mhm,
But this is where it differs from the superposition then, where maybe it doesn't collapse. Um,
right, entanglement doesn't collapse. It's just two particles that are so intertwined that they
it's the same
that
system.
whatever happens to one affects the other as well.
Yeah, so it's the same system is basically, and it doesn't matter how far it is.
Right.
They're already connected. Now,
Yeah.
this is where Einstein was not happy with it, because Einstein's thing was, well, if this is true, then relativity is debunked, and we already proved relativity, so it can't
Hmm.
violate relativity. So like it almost can't work this way. And I think it was Bell who said, well, fuck it, let's put it to the test. And there's I think John Bell, I think that's his name, had the math for it, and like let's set the limits, and here's what should happen and what shouldn't happen. And through these experiments, it broke those limits every single time. So
Right.
there was entanglement. There was in the experiments. There was entanglement. Entanglement. You mess with one particle, the or other particle also has an instantaneous movement or reaction in the same way or an opposite way. I'm learning now. So there's already proof that this has it's happened, but also it never violates um relativity, because it never goes higher than the speed of light, because there is no information. They've tried to measure information, and there is
Hmm.
no usable information between one or the other. And I think that's where the TikTok physicists,
Hmm.
they like to say, well, there's information traveling and it's happening so fast. And I think this is where people think about telepathy and all of that stuff. And there's no evidence in all of the the experiments that there's information shared, so you can't violate the the rules of relativity. You can't violate those laws.
Right. So, I mean, basically, all that is correct. Correlation pretty much shows up instantly, but you can't control or transmit it intentionally. So, it's like the universe basically give you notification after it already made the decision. It's
And
basically
this is
telling
where
you.
it breaks humans. This is where it breaks every this is what we don't know. And this is the
Hmm.
fucked up thing about quantum entanglement, is just like we can prove it, we can show it, we just don't know why.
Right.
We still don't understand 100% why this happens. This is true for superposition. This is true for quantum computing. This is why we don't have quantum computers. This is like we just don't know. We don't know. We know the end result and we have the measurements. We just don't know the math to understand why it happens. We know the math for the possibility, which we describe as wave function, but we
Hmm.
don't understand why it happens. We don't understand why these particles do what it does.
We need those people to chime in because they get paid a lot of money, and that's
But they haven't figured it out. So
they haven't.
that's the problem. I know they're trying to figure it out,
Right.
but I haven't seen. I tried to look it up. I haven't seen too many humans with, because at this point we're looking for a PhD student who is working on a thesis to add to this field, and there hasn't been much in any of that stuff.
So you have, you're talking about quantum computing, and of course the the qubit, pretty much, which is what
Yeah.
everything is being stored as. So that's an example of superposition. Superposition would be the backbone of the qubit, because you have everything. all information being stored in every single state at the same time until you're able to pull up the information or you're able to observe that information. Um, and that's why you were saying that in quantum computing, the qubit is not a good way of storing information because it's stored in every existing state
until it's measured.
until it's measured.
Not
Yeah.
only that, but I'm finding out that it has to be pretty cold in order for these qubits to be maintained stable. They don't do
Mm.
well with heat because of the we're limited on the hardware that we can use to store the qubits. In a lot of electronics are copper and just heavy metals overall. Platinum, gold, I think they use in computers. I think platinum and copper really more than anything else. Computers have a little bit of gold. But I was watching a video this morning and it talked about how incredibly cold it had to be in order for this to be stable. Once it reaches a certain temperature, then these qubits kind of disintegrate. They're just not stable anymore. They're just not stable. The way they interact with the copper just no longer stable, which is just wild to think about.
Yeah.
But this is where it's tough. This is where it's tough. I'm sure AMD, I'm sure Microsoft, I'm sure Google are investing a lot of money, and they have maybe some physicists that can figure it out. But fucking crazy. It is.
So
It is.
so one of the things about quantum entanglement and some of the things that I think I've written some little small studies about quantum teleportation as well as small form time travel with some of these with the entanglement particles. They've moved particles, you know, to different time states or something like that, and one that they put in one area was able to affect the one that's in another area that was in a different time zone or something like that. I don't know exactly how the experiment went.
Yeah. Do you know what experiment it was? I'm sure we can Google that really quick. And I think this is where I don't have enough information. This is where my Dunning Kruger starts to kick in, where obviously I think I know more than I actually know, and I have to check myself on this stuff. But the time travel thing, I don't think there's been enough evidence for me, the idiot, the ignorant human, to really believe in all that stuff. Because again, in entanglement, from what I understand, it's the same system. It's not me being able to time travel to another place. There's no information being shared. So if there's no information being shared, then there's really no time travel.
Right.
Because if there was time travel, then it would have to violate the speed of light, and we already know that you can't have something happen before the cause. There can't be an effect before the cause. It's cause and effect, not effect and then cause. Um, I hope I'm saying that correctly, but it,
So,
it's it's weird. Go for it.
so yeah, they were trying to study backwards time travel with entangled particles. They said by manipulating one particle, researchers can retroactively influence the past state of its entangled partner, effectively creating a quantum closed time loop.
All right, so you
Um,
broke up there a
what?
little bit.
Uh, oh,
Your
sorry.
your DSL internet is
They are
so
working
they
on it.
they
We
had
had a
two
whole power
particles.
outage, right? Yeah. So two particles.
Did you guys?
Yeah, yeah. Did you see that the whole substation that blew up?
No, I didn't. I heard about some power outages here in the state of Colorado in the Denver metro area, but
Yeah,
um,
it
we didn't
was
get
pretty big.
affected by it. But
Uh,
oh shit!
yeah, my kids knew about it before I did. So,
You
so
got to get
they were
that white
saying,
people internet, dude. You
yeah, I
got
know.
you. Yeah.
It's coming. It's coming. They saved us for last. So it says by manipulating one particle, researchers can retroactively influence the past state of its entangled partner, effectively creating a quantum closed loop.
But how? Like, what was the experiment? Does it explain how the experiment happened? And we may not have
So
enough. Go.
it came from University of Cambridge.
Okay.
So not physically sending objects back, but they can use entangled particles to change the results of the past or already completed experiments. That's strange. Okay.
Okay. So an analogy, an example would be is, and again, this is just an example. I type up an article, and in the future, in a different piece of paper, a photocopy. Well, we'll do that. A photocopy.
Hmm.
I scan it. I photocopy. Now I have two. One is the original. One is not. I take the original, leave the photocopy in the past. I have the original with me in present time. I erase something, and as I erase something, it is erasing and updating in the copy as well, without it being an electronic form.
Yeah, it sounds very Mandela effect ish. Maybe.
Maybe. So I think the Mandela effect is just what we remember. It's a different reality that we remember, but it's not. It doesn't happen to be true. But this one would
Correct.
be true. This one would be. This is actually what happened.
Hmm.
I erased one paper, and then without me interacting with the photocopy, it updated the photocopy non-electronically, but at a quantum state. That's basically the analogy. Maybe I'm doing it disservice, but that's basically the analogy. And obviously, we don't know how they tested it. I'm sure we can spend some time on figuring that shit out, but that's
So
weird.
what they're trying to do as a practical application says that they're trying to improve quantum sensors to make them behave as if they're receiving information from the future. I guess to make sensors faster. So almost like they're able to see see something that's happening before they actually reach that stage by signaling to the quantum or its entangled state
Yeah,
before it.
I'm gonna have to read that. I'm gonna have to I'm gonna have to find a video about it because I don't want to read it. It sounds like a lot of words.
Yeah, it's a
Um,
lot.
huh.
Yeah, it's just simulations of time travel, not necessarily actual time travel.
Oh, it's a simulation of. This is where these articles and these studies get me all the time. It's just like they tell you these really magical shit, and then you read the article like, oh, it's not really that.
It,
And I
it
should
was
know better. I should know better because they do it all the fucking time. And I fall for it all the time too.
yeah, because you're interested.
Well, not only are we interested, I think, and this is just the theory, obviously, is um, in we see these with conspiracy theorists. Is I don't know, so I have to make something up to be a reality. I don't know, so I have
Hmm.
to try and make sense of what is real. And we see this in everything. We see this um, in in the moon landing, and we see these in the. We were just watching a video yesterday about the pyramids, but we see this a lot with people who don't know how the pyramids happened, and they just make shit up to try and make sense of it because we hate not knowing. Um, we absolutely hate not knowing. So then you get humans
Yeah,
who read these articles, and then we just make shit up,
that's pretty
and
much
then we
it.
get bad TikTok information.
TikTok.
Um,
What about
there's a lot of
Bell's theorem, though?
the bells. What
Bell's theorem. Have you checked that out?
is it? The same bell, or is it a different bell? Because the bell that I know of is John Bell, and he's in quantum entanglement. He's the one that came up with
The
the
inequality.
the inequalities. Is that the same
Yeah.
Bell?
Yeah.
So what are you talking about then? The Bell's theorem?
Bell's theorem with his pigeons and holes.
Yeah,
Um,
explain it.
yeah. So you have 11 pigeons and 10 holes that you put them into. However, it doesn't really matter how you distribute it.
Okay.
There's 100% chance that one of those holes will at least have two. So that's pretty much the simple way of
One of
doing
those
that.
holes is gonna have two
Two
pigeons.
pigeons. Yeah.
All right, so
So you can
you have 11 pigeons and how many holes?
10.
10.
Hmm.
Okay, but what's the
So it's just it gives a mathematical equation, or at least 100% that one of those holes will have two pigeons in it. It's the inequality theorem is that one hole is going to have two pigeons. That's all it is, and
Yeah, but
that's
I thought
your it takes away the
but I thought in quantum physics, and I'll look at my notes here. I thought in quantum physics it broke this inequality. Bell asked if particles have hidden instructions, they must obey certain statistical limits. Um, Bell's inequalities: if hidden variables are real, measurements can only correlate this much, like an amount, an amount.
yeah.
So when they ran the experiments, quantum mechanics violated Bell's limits constantly. It was consistent violation of Bell's limits with increased precision using photons, electrons, and atoms, meaning there's no hidden local instructions, no pre-written answers. The universe really is what it's just weird.
Hmm.
And this is where Einstein was um, his he never had a theory on it. He just had more of a thought experiment. Einstein, if I'm not mistaken, he never had a real answer of this. He just at the moment was skeptical about the stuff.
Right.
But in entanglement obviously was real. Um, so this is where it's confusing because I do understand. I think we're talking about the same thing. Bell's inequalities, but quantum physics, quantum entanglement basically broke all of that stuff. It violated those limits, which is how we were able to prove that. I hate to say this, it hurts my heart, but Einstein, his intuition about quantum mechanics was incorrect. But it still doesn't violate his laws. It doesn't violate the laws of physics. It actually works within it. We just don't know how.
Hmm. It works within it at a minute scale, at a very tiny scale.
Yeah, it doesn't
Whereas,
scale. Yeah, it doesn't scale properly. The funny thing is that it affects our life enough that sure it doesn't scale. Like we can't see this in classical physics, right? My phone is not going to mess with my family's phone, even though it's in the same system. Like it's not going to do that, but it's enough that it affects the way the universe moves and particles move and um shit, this might be a path towards figuring out what antimatter is. And again, this is just the theory. I don't know if it's true. I don't know how it's even connected, but I mean
right.
there's a potential where it explains all of that stuff. And I think that's where people are just trying to find these answers. I do have a few things here about it. How entanglement gets abused in pop science.
Mm.
Entanglement lets you send messages instantly, and that's not true.
No, that's
Consciousness,
definitely not true.
what's that?
I said, no, that's definitely not true.
Correct. Consciousness collapses the wave function, and there's no zero evidence that consciousness, um, a human basically, collapses the wave function. That's not true either.
Yeah.
We are all entangled, so thoughts affect reality. That's not interaction and entanglement are not the same thing.
That's another theory. They're talking about the one particle theory or something like that. The one. Have you heard of that one?
No.
I think it's one particle theory or one electron theory or something. I don't remember. It's a
Uh,
where they're saying that the universe is basically just one atom, pretty much, or one one particle, and
we're
everybody's made up
within
of
the
different.
atom. We live within
Yeah,
the atom. Yeah.
yeah.
Try and find that. Try and find that really quick. See if you can find that study or that thought experiment while I um kind of look at this a little bit more. So yeah, that was the last one. We are all entangled, so thought affects reality. Everything interacts, and that's just not true. Interaction and entanglement are not the same. Reality isn't made of independent pieces. This is like the truth. Reality isn't made of independent pieces. Relationships are fundamental. We're not talking about human relationships. We're talking about, and I think this is where people on the internet fuck this up. Is they hear words that we use every day, and they
Hmm.
try and associate that with what is real to us. But it's a relationship between quantum stuff. It's a relationship between quantum stuff. Measurement isn't passive; it's participates. Um, it doesn't mean magic, destiny, cosmic vibes. It means the universe is less like Lego bricks and more like a single fabric you can't fully tear apart. Um, so a summary that I've got here that I had ChatGPT help me out with, and again, might be wrong, but this is how I use ChatGPT. I have a thought and I tell ChatGPT, "Here's my thoughts. Organize it for me." I try not to ask ChatGPT for info, but more to organize my thoughts. Einstein says this can't be right. Bell says let's test it. Nature says Einstein was wrong. Hurts my feelings again, but it is what it is. Pop science says so. Your thoughts control the universe. Physics, absolutely not. That's not the way it works. The biggest problem though is, and the reason why pop science wins is pop science because we don't know. We don't fucking know.
Yep.
Pop science can kind of get away with all kinds of shit right now because we do not know. And
Yeah.
physics is just like we have the answer for you. We just don't know why it happened that way. Did you find it?
Yeah. So I found a little synopsis of it. One particle theory, or it says more accurately, the one electron universe.
Okay.
It's a thought experiment proposed by physicist John Wheeler,
Okay, Wheeler. Yeah, yeah.
suggesting yeah, suggesting all electrons are the same single entity moving back and forth in time, explaining their identical properties and creating positrons as time reversed electrons. So basically, it's we're all the same electron in different states or in different positions,
We
I
are the
guess.
superposition.
Yeah, yeah.
Kind of we are the superposition.
Hmm.
But that wouldn't work because we've already been observed by one thing or another. I'd have to read that a little bit more. But Wheeler is
Says,
not a no name physicist. I mean, Wheeler is um he's not super well known, but I mean,
yeah, so it says single electron whirl line zigzagging through spacetime. When moving forward, it appears as an electron. When it reverses direction or moving backward in time, it's observed as a positron or its antiparticle. Um, it explains why all electrons are identical, same mass, charge, and spin. They're all just different moments of the same fundamental particle.
huh?
That's
Yeah, that's weird.
that's layers right there.
That's a lot of layers. That's a lot of weird shit.
Hmm.
Which is the universe. Um, which is the universe. I mean, shit. We still don't know the real why to a lot of stuff. So it shouldn't surprise us that we don't know the why to quantum physics.
Yeah.
It's actually mind-boggling how little we know about how any of this shit works. Shit, we don't even know how the ocean works. We've explored the ocean very fucking little, and that's on our planet.
So I'm reading what can disprove it. Basically, it's asymmetry. It says the universe has vastly more electrons than positrons, which doesn't really fit the idea of a single particle
Yeah,
just constantly flipping directions.
yeah, because then you'd have the equal. You'd almost have to have equal positrons as electrons.
Right. And we still haven't found antimatter anyway. So
Well, we know it's there.
yeah,
We just don't know what it is.
exactly.
Correct?
Hmm.
Because antimatter is what we used to call dark matter,
Hmm.
if I'm not mistaken.
Which they said that for fractions of a second, I think through the Large Hadron Collider, they've been able to get it to kind of pop in or pop up for just fractions of a second, but it disappears as soon as any state of the particle starts. I like that off. I
Uh-oh.
didn't cut that off.
So some bald white dude in Africa just turned on his lights, and that's why your light turned off.
Yeah, yeah. That's pretty much it. Right on the other side of the world.
That's why your light turned off.
Daggone entanglement.
Some white dude in Africa turned on his light, your shit went off. That was weird.
Yeah.
Uh, well, I'm pretty happy with what we've talked about. Hopefully, it made sense to humans. I don't know if you have something else that you wanted to add to the conversation. Um, any clarifications, any experiments, any of that stuff that you want to talk about?
Um. Any experiments? No, nothing new. Nothing that I've been really looking at. I've been really busy at work, so it's like,
Yeah, yeah, for sure,
yeah, yeah.
for sure. I guess one last thing for me is, I think to clarify for humans that are on our level, not humans that are smarter than
Hmm.
us, and hopefully humans that are smarter than us at some point start to comment on a lot of the dumb shit we're saying, or maybe eh, kind of saying that we're not saying super dumb shit. Um, with the Bow's limits, I meant to say this earlier, but I didn't talk about this. Um, breaking Bow's limits means at least one of these must be false. Results existed before measurement. Distant things don't influence each other. Quantum mechanics says pick one or accept that reality is stranger than both. Most physicists accept measurement doesn't reveal reality; it creates the outcome.
Hmm.
So, and I think that's the weird shit. There is measurement doesn't reveal reality; it creates the outcome. So that's what's mind-boggling is reality in quantum mechanics, in quantum physics, not at a large scale, but in quantum physics, kind of isn't real until you measure it. Um, as I
Right.
understand it.
So that gives my own definition of the observer effect. Basically, we influence the world the moment we pay attention to it. So that's it.
Yeah, but I think that's more of a philosophical, um,
It is.
human level, which
Hmm.
I think it's correct. I don't think what you're saying is correct, incorrect. I'm sorry. Um, I just don't know how it
Yeah, I
works
mean, if a
on the.
tree falls in the forest and no one's around to hear it, doesn't make a sound. That's the philosophy behind it.
Yeah,
Um,
but I think in quantum mechanics, in quantum physics, the answer to that question would be yes, it does make a sound because something was there to hear it. It might not have been a human, but a bear
mhm.
heard it, bird heard it. Like it might not have been you, but it still
Yeah.
existed. It was still it still happened. So the answer to
Well,
that is yeah, it did still make a sound. Um,
well, part of quantum physics is, yeah, it doesn't have to be a human. It doesn't really necessarily have to be something that's alive, because it considers the entire universe as
all of
alive
it,
anyway. Yeah,
correct.
so
Yeah,
anything can be observing it. The wind can be observing it.
which is weird. That's how
Yeah.
self-absorbed we are, though, as a race. That when all of these words get said, we automatically think, and I'm guilty of this too, because this shit wasn't until recent where measurement does not need to be like I thought measurement had to be measured by us, the human, and then
Hmm.
that's where and then I started studying this a little bit more, and again, just until fucking recently, like super recent,
Right.
did I understand that it's not about a conscious observer; it's just observer. Period. Um, period. So that's crazy. That's crazy. Well, at any rate, if you have no more stuff, I have no more stuff. I hope this was at least somewhat interesting for two of you guys or one of you guys. I know for most humans, this shit is not interesting in any way, shape, or form.
Hmm.
I'm kind of hoping that science becomes interesting for a lot of humans. But I talk about science in the classes that I do professionally, and you can see a lot of humans like I don't know, like I came here to learn how to shoot a gun, and then I start talking about physics, and then people are like, I what the fuck? So I get it. For a lot of humans, physics is not super interesting, but for me, it's one of those like I wish people would understand this more, and that way we'd have less flat earthers in the world, and a lot less of humans who believe aliens created stuff. Um,
Yeah.
because
But once you start pulling it into psychology as well, that's when it really gets interesting.
oh,
That's
we might dabble into this though. This does say science dum dums. It doesn't say physics dum dums. So like that's still science.
yeah.
Um, absolutely, absolutely, for sure. But anyways, I appreciate you, dude. Thanks for the conversation. Um, again, I like doing this stuff. I like having these conversations. Hopefully, other people enjoy them as well. Um, just do the sharing and the liking and do all that. Who knows? Maybe we might do this professionally at one point. Um, at any rate, anything you want to plug? You got books, you got videos, you got your
No books
Facebook,
yet. Books may be coming on the way. I
maybe.
have Yeah, I have an entire series on ADHD cognition. As everyone probably knows already, I'm ADHD, so I started speaking from lived experience and writing these little short essays about different aspects of ADHD. And
Where could
uh,
people find them?
I mainly post them on Facebook and LinkedIn. Facebook is actually my my strongest post, and I post them every Monday morning. So yeah,
Okay.
you can check them out. Brand new one, but they stay up, so you can always scroll back in my timeline and read them.
So that
So yeah,
you can find it at Facebook, just Richard Fletcher,
yep, yep.
just the name Richard Fletcher. You'll find it. I kind of scrolled through some of your stuff. Some of the stuff maybe we should talk about on here.
Mhm.
Um, I'm still looking for that other 5,000 like post, dude. Those
It's never
algorithms, man.
happened again. I don't know what
That
was happening.
algorithm is so weird. This is how we know the algorithm is not in our favor in any way,
Yeah,
shape, or form, because that's bonkers. That is absolutely bonkers.
about
Um,
graphene of all things. Like, okay, the most boring subject that I've posted. I've
so
posted some
crazy,
interesting stuff, and it was like,
crazy.
why did this one blow up?
Yeah, yeah. So go check out Richard. I've got nothing interesting going on. This is probably the most interesting I've got going on. And you're already watching it where you're watching it. So I appreciate you guys. Thanks a lot. Thanks for the two of you guys that are watching. It's probably my wife and one other human, but hopefully other people are watching later on. Super duper appreciate